Hello, everyone. Welcome to this presentation for the ARRL Learning Network, an initiative of ARRL, the National Association for Amateur Radio. There are so many ways radio amateurs can discover new ways to enjoy our pursuit of radio technology and communications. And this webinar series is our way to help connect experienced members with all members so we can share knowledge and experience. So thank you all for being here today. I'm Chris Bickle, K1BIC. I'm the Lifelong Learning Manager at ARRL. I'm a member of the Learning Network team and today's webinar moderator. Today's presentation is Maxim Memorial Station W1AW Tour and is presented by W1AW Station Manager Joe Karsha, NJ1Q. The session will be recorded and will be available on the Learning Network page within a couple of hours after the session is over. And during the presentation, we encourage you to submit questions using the question box found on the bottom right of the screen. We'll try to get to as many questions as possible during the Q&A period following the 30-minute presentation. So let's start the tour.
Hi, I'm Joe Karsha, NJ1Q, the station manager and trustee of W1AW. W1AW, the Maxim Memorial Station located here in Newington, Connecticut, at the headquarters of the American Radio Relay League. Now, for those of you who are familiar with Maxim Memorial Station, or W1AW, we are the national organization station. We are the face, if you were, of amateur radio and for the organization. This is the flagship station for the American Radio Relay League. Now, here at W1AW, our primary mission is the transmission of code practice and bulletin transmissions on 9 amateur HF and VHF frequencies. In addition, we also offer multiple operating positions for visiting hams to come in and operate the station using just W1AW. They can operate on those bands and modes granted by their license class. And we will see those operating positions in a few minutes. Now, a little bit of history. This is not actually the first radio station used by the organization. The original station was located about 5 miles to the north of us in Hartford, Connecticut, and was licensed as actually 1MK. In what was called the Great Flood of 1936, that original station was destroyed. Now, rather than rebuild that station, which subsequently that whole area was flooded again in 1938, the organization at the time decided to purchase this property here in Newington, Connecticut. About 7¼ acres here in a very rural area of Newington, which is actually a suburb of the capital of Hartford. And the radio station was built. Now, at the time, there was pretty much nothing around here. This was kind of farmland. And so the station itself, this brick building, the iconic brick building, stood out amongst everything else. It was so rural that they actually had to install a water line on Main Street just to get water to this building. Now, construction started in late 1936, and they were finished actually in July of 1938. And W1AW was officially inaugurated on September 2nd, 1938, September 2nd being Hiram Percy Maxim's birthday. Although we were operating as 1MK at the original site, the organization at the time had petitioned the FCC to use the call sign W1AW in memorial. So since 1938, we have been active as W1AW from this location, sans the World War II years. Now, since that time, the station has grown a little bit. In 1963, when the first part of ARRL headquarters was built, a foyer was added to the station. In 1989, the station went through a complete renovation. They changed the actual structure of the station. For those who may remember the station prior to 1989, this was a relatively open area. The transmitting racks, which I'll show in a few minutes, were traditionally located along this wall, but as part of the renovation, they could have been located anywhere. Of course, the operating studios at the time were out in the open, so if you had more than 3 or 4 operators in here, it got quite noisy. With the renovation, we have these studios. there's actual felt on the walls, which kind of helps deaden the sound a little bit. So on a good day, when band conditions allow, and of course we're allowed to have visitors, I can have up to 9 operators present here. And usually that happens when we have large groups visiting the station, or of course during high contests like any of the ARRL DX contests, or even some CQ. But as I said earlier, the main goal of W1AW is the transmission of code practice and bulletin transmissions. And I would be remiss to not include in those transmissions qualifying run transmissions. Those are a award which is available through the organization, which allows individuals to test their Morse code copying proficiency. Now, all that transmitting, all that scheduled transmissions, all that broadcasting, and I should note that broadcasting is used purely in a technical sense because amateur radio operators are not allowed to legally broadcast, but all that broadcasting is done with the equipment here. And if you'll bear with me for a second, I'm going to bring the camera over. I'll try to do this slowly so individuals' eyes can adjust to see just some of that equipment. As I mentioned earlier, we're transmitting on non-HF and VHF bands, specifically 160, 80, 40, 20, 17, 15, 10 meters, 6 and 2 meters, running anywhere from 800 to 1100 watts on those bands. Now, you may notice that the top of the transmitting racks have the word Harris. As part of the renovation, we were using all Harris commercial grade equipment, specifically the RF3200 series. Well, that was all well and good back in 1989, but as the years progressed, the equipment started to fail. Repairs became more numerous, the expense of the repairs were becoming more and more expensive, so we decided to look at amateur equipment for a viable replacement. And we've actually gone through a couple of versions of amateur gear in this setting. We had modified Tentec Omni 6 Pluses. We had modified Command Technology amplifiers. We finally settled on the complement of equipment we have here. It is mostly ICOM. We do have Yaesu and Kenwood represented here as well. And of course, a Harris Platinum amplifier for 6 meters, which is actually a modified amplifier. But this is all amateur grade equipment. In addition to the ICOMs, Yaesu and Kenwood, we also have ACOM 2000A amplifiers, Alpha amplifiers, and of course, a PW1, an ICOM PW amplifier that we use on 10 meters. All this equipment is used to transmit all of our scheduled transmissions simultaneously. We generally run about 40 hours a week code practice, and that is a requirement from the FCC, specifically Part 97113D. And of course, running high power into high gain monoband antennas, we do everything we can to maximize our coverage. Now, all the keying signals from this equipment is handled by these 2 computers here, and I'm going to bring you over there quickly to show it, and hopefully you can see it. We currently have 2 computers that we use. One is used to generate just the CW keying signals, the other all of our digital audio. Now, the program we use for CW, that was written in-house. That keys a DRSI packet card, which in turn keys a matrix, which was built by the ARRL laboratory as part of the renovation. Again, that handles just the CW and PTT keying. The digital transmissions, and currently that is RTTY, PSK31, and MFSK16, that is handled using the program FLDigi. Now, when we incorporated FLDigi as part of our digital transmitting setup, we had worked with the author to modify the program just a little bit. And the reason I say that is because under normal circumstances, any amateur radio operator using FLDigi is using one mode. They're running Olivia, or they're running MFSK16, or they're running PSK31, and it works fine for them. For us, we have to send up to 3 different modes within a scheduled time frame. So we have to be able to switch immediately or nearly immediately within the course of that transmission. On any one day, I may be sending RGTY, PSK31, and MFSK16, depending on length of the bulletin. So when working with the author, we were able to come up with a series of macros that allowed us to switch modes in the midst of a transmission. Now, FLDigi is constantly updated by the author. And in doing so, that will allow us to eventually use that same program to also handle all of our CW keying as well. There's just a few minor hiccups we have to work out with regard to the keying. Now, FLDigi always ran CW, but at the time it was strictly audio. We didn't want to inject audio signals into the equipment and send CW. Rather, we prefer the actual keying using the radio's actual CW jack to handle all the CW keying. With the new version of FLDigi, that now happens. It's just a question of importing everything over, the file structure, and so on. So when we generate our CW files, the program reads them, sends the keying signals over to the keying matrix, and keys all the transmitters simultaneously. Now I'm going to bring it back over here. And you may or may not be able to see all the frequencies, but if you're familiar with our schedule, you'll know that our CW frequencies end on the half kilohertz. For example, 20 meters, we're transmitting at 14,047.5 megahertz. That's what it says in our schedule. Now, the FCC says we're supposed to be where our schedule says we're supposed to be, and that's all well and good. But 14,047.5 does not mean 0.582 or 0.561. We understand it to mean 14,047.500 kilohertz or megahertz, depending on the point of view. If you see these radios, you'll see some of them have some really odd numbers after the half kilohertz mark. On 17, it's 501. On 15, it's 513. On 10, even though you may not be able to see it, it's 0.499. The reason for that is we don't necessarily use the display to tell us where we're transmitting. We will actually measure our transmitted frequency, and I will do that 2 to 3 times a month just to ensure that we are exactly on frequency. And therefore, what I will do is I will adjust the display or the radio itself so we are exactly on our transmitted frequency. Now, we generally use a Hewlett-Packard for that. The HP has a 10 megahertz reference that we're deriving from a GPS standard. And you may also be able to see it. I'm going to bring the camera a little bit over this way here. Some of you may be familiar with the old HP spectrum analyzer. We will also sweep our transmitted signal just to check it. I may do that once a month just to make sure that everything is okay, everything's on the up and up. Whereas the actual frequency measuring test that I will do to ensure that we're exactly on our stated published frequency, I will do that 2 to 3 times a month depending upon the schedule, how we do with visitors, and so forth. All this equipment here, I'm going to bring the camera around again, and hopefully you can see it. All this equipment here, let me just bring this camera down a little bit. This is used strictly for all of our scheduled transmissions. The panel over here to my right is used to control the power to the transmitters. We can also control the keying of each transmitter, PTT keying, either simultaneously or individually. If I have to shut down the transmitter, I can do that without taking the whole system down. And we also have some audio boards here, which we use to take the audio from either the program FLDigi or the microphone, because we still do have a single voice bulletin at 9:45 p.m. Eastern Time, Monday through Friday. So all this is used strictly for all of our scheduled transmissions. Now I'm going to bring the camera over and try to give you a larger view, and hopefully you're catching this, of our operating studios. And please excuse the signage. We understand why the signage is here for COVID-19, but it's all over the place. These are generally the 3 studios that we use to allow visiting hams to come in and operate the station. And we have a variety of pieces of equipment, and pretty much all the major manufacturers are represented here. Yaesu, ICOM, Kenwood. We do have some other manufacturers like Heil, ACOM, Alpha. They're all represented here. And this is here for any visiting ham to come and operate the station. While the ARRL is a membership organization, the use of W1AW is not. W1AW is here for all licensed amateur radio operators. And while we would certainly encourage membership, support of the organization because it is important, this is here for the benefit of all amateur radio operators, both domestic as well as foreign. And we have quite a number of foreign hams that come in here and visit the station. And I can say with a fair level of pride that a number of foreign hams, when they visit this country, if they can, they will make a stop, a special stop to come to the organization, to come to ARRL, and to visit W1AW and to get on the air and hopefully work their friends back in their home country. Now, each studio has at least 2 HF operating positions. By that, I mean anything from 160 to 6 meters. CW, phone, digital, all can be done from the radios here. The second studio, there's a little bit more going on in there. In addition to having at least 2 HF operating positions, we also have our Windling 2000 station operating there, our APRS, our satellite station. We actually use an ICOM IC9100 for that. And we beacon our weather from that location as well. So there's a lot going on in Studio 2, and I'm going to give a quick sweep of all the studios so you can kind of see what's going on in each one. All logging is done using N1MM Logger Plus. The beauty of that is, since we're on a network, all the systems are networked together. So if I have visitors in, say, Studio 1, and say some visitors in Studio 3, they can see where each other are operating. Now, granted, given our restrictions on antenna placement here, it's only 1 person per band. In other words, I cannot have, say, a CW and a phone operator on 20 meters. It's either CW or phone on 20 meters. But then again, they can see where each other are. So what I encourage my visitors to do is, if in the midst of a conversation and there's more than 1 operator on, I will tell them to tell the person they worked, look for W1AW on this other frequency and mode. And what's cool about that is hams will chase us. If I have somebody on, say, 40 and 17 meters, they'll work us on 40, they'll try to find us on 17 and work us at the same time. So that's pretty cool. It gives someone who out there who's never worked the station a chance to work us on more than 1 band. Now I'm just going to quickly bring the camera over, and again, I apologize for any jitter that may occur. And you're hearing the fans going on in the background for the equipment. So this is our first studio. We have an ICOM IC7700, and that's married up to an ICOM IC-PW1 amplifier. Over here, you may be able to see it, maybe not, hopefully you could, is the Yaesu FTDX9000D hooked up to the ACOM 2000A amplifier. Again, all for visitor use here. And of course, when staff come in and operate contests, and W1AW normally operates contests to give out the call because hams like to work us, and sometimes that's the only opportunity. But that does not mean that we cannot participate in contests with the possibility of winning. And of course, I can show off all the plaques we have hanging on the walls indicating our winning particular contests. Again, we never do that to win the contest, but since it's W1AW and the joke is the call adds 10 dB to the signal, a lot of hams work us, so generally our QSO count is fairly high. Now here is our second studio. And I'm going to just drop the camera here. We have the IC9100 in the corner there. We use that for HF as well as VHF and satellite work. I am in the midst of changing over our satellite equipment, which is why you see the controller stuck out there in the middle. Our second studio is used for 2 meters. It has an HF component to it, but generally that's our WL2K, our Winland 2000 station. We are set up here as a node. And of course, we have a Yaesu FT2000, which is another HF operating position. But right now, what I have on display here is our APRS. We use pinpoint APRS software to have W1AW represented within the APRS network. Of course, we're going to come over to Studio 3. This is the beauty of a USB tether. I can actually bring this camera around. We have the FTDX 5000 that's married up to the Quadra amplifier, and a Kenwood TS590S that's married up to an Alpha 9500 amplifier. Also, two HF operating positions. The Kenwood 590, I like to use that when we're running FT8, and although some of the other positions do have digital operating. Now, one more station we have, actually two, kind of, sort of, and I think I'm going to start running out of tether here. And please excuse the messiness of the desk. We're in the midst of, again, getting a computer ready for migration over to FL Digi, but also we're taking care of a few other computer issues. That's why it looks like there is a mess on this desk. But this is where we have our D-Star radios. We're a Mars station, so we also operate Mars from here, or Mars activity when we try to check into the nets. That's all done here. We also have another HF operating position, which is used as a spare. And over here, I'm going to try to pull it up. We have our ARRL station. We are node 4292, and I usually try to monitor it. Now, it's a little messy because we're still in the final testing stages, but we're actually using a Raspberry Pi. I'm sure you can see that. The Raspberry Pi with the ARRL board for all of our ARRL. And let's see if I can get a little better shot of that, see if I can bring it a little closer. Now we have that primarily for MCOM use, but again, I also monitor the node just in case anyone wants to try to connect to us via ARRL. But also if I have visitors who want to speak with their friends back home via ARRL, they can do that as well. Now over here, we have, although you're not going to see it, we have a weather satellite receiver, which is actually part of our education technology program, which we use to receive weather satellite images. I'm going to take you back over here to the patch panel. I'm just going to make sure that my tether is working. And I just got to pull these doors back. These are used for sound. Hopefully you can see that. This is the patch panel we use to hook up the antennas for both the broadcast equipment, again, broadcast purely in a technical sense, to their individual antennas, as well as the patch panel we use to hook up the various radios in each one of the studios to all the different antennas. With the possible exception of 1/1680 meters, I have two antennas for each HF band. I have 2 for 40. I have actually 3 for 20, 3 for 15, 2 for 15 and 10, 2 for 17. VHF and above, specifically 6 meters, 2 meters, 77 meters, is handled a little differently. But this is generally all the HF and 6 meter connections are all done from here. I also have connections which take us into the workshop, which I'll show you shortly. Our foyer, which we sometimes have a station set up in the foyer, mostly for demonstration purposes. I have lines that actually go down into the cellar, where you see this test cable that actually is our patch panel downstairs, or bulkhead, which unfortunately I will not be showing you on today's presentation, but just realize that it's there. We also can connect, and hopefully I can get you to see this, the towers, which have rotators on them. This connections here allows me to connect each one of the rotators to each one of the towers, our north, center, and south. The towers are all Roan. I have 3 60-foot self-supporting SSV and 1 Roan 65, which is 120 feet. The Roan 65 is actually housing all of our broadcast antennas, with the exception of the 2 rotatable, which are also used for visitor operations. And of course, you can actually see a little better some of the equipment that we see here, like the ICOM 7410, the 7300, and so forth. Now, we have a lot of ICOM equipment in here, and I should have mentioned this earlier, but we are not supplied with equipment for the broadcast stuff, for the scheduled transmissions. This stuff we will actually purchase on our own. We do that so we have all the warranty that comes with purchased equipment, but also because we don't want there to be this assumption that we are favoring one manufacturer over the other. In terms of the 7300, it is a very small radio. It is a very inexpensive radio. In terms of what we need, it fits the bill perfectly. Were Yaesu or Kenwood to come up with something similar, we would get that. We are not beholden to any manufacturer for this, which is why I'm using like an Alpha 87 right now on 80 meters, and I'm using ACOM 2000A for all the other bands because for this particular setting, this equipment works well. It's also not to promote any manufacturer, but again, for what we need this to do, it fits perfectly. Now, I want to show you into the workshop because we're all engineers there, and you need to see that, yes, we actually do have a workshop. This is our workshop here, and just so you know, it's kind of cleaned up a little bit. I did that purposely. Although we do a lot of stuff here, we try to do repairs here when we can, obviously a little bit of testing when we can, and of course, building. We try to build a lot of the stuff that we can use. Because, while yes, there is equipment out there that we can purchase, like interface and so on, there is something pretty rewarding about building your own stuff, especially for use in amateur radio. So it's not always this clean, but like everything else, we know where everything is. Don't clean it up, otherwise we won't be able to find anything. Now, we all know about CW, how it's generated and so forth in equipment and what have you, but way back when, in Hiram Percy Maxim's time, the only way to transmit CW was by generating an arc. I'm not too sure how you can see this. I may have to move the camera over. But behind the 3/8 polycarb is Old Betsy, which is Hiram Percy Maxim's rotary spark gap transmitter. I won't demonstrate her, but just take my word for it when we say that it does function. She does function quite well. We essentially are sending a keying signal over to a triac here, which puts 120 volts onto the high voltage section. And of course, since we're keying it with a Morse code key, we get Morse code generation with the arc. So I'm going to bring the camera over here. And I'm outside the view of my monitor, so I cannot actually see how well you're seeing this, but I'm going to bring this up a little bit. And hopefully you can see the 4-point rotary, which normally does spin, but there's a little bit of friction because of the motor. Might be able to see the motor on the side. And of course, some of the other pieces to it, specifically the high voltage transformer that generates about 12,000 volts AC, and the oscillation transformer and the capacitor. 12,000 volts AC goes to the coiling capacitor. It's placed on these 2 points, and hopefully we can see the other side, maybe through it. Here's the other point right here. With the high voltage and the spinning armature, with the voltage being keyed with the CW key, this 4 points comes close to either point without actually touching. We create an arc. That information is coupled back through the oscillation transformer and to your antenna system, and of course, a CW signal is transmitted. And that's how she was used up until about 1928, when obviously we had actual CW or continuous wave transmission. It was cleaner, much more efficient, and Morse code was made illegal, although we can still transmit it for demonstration purposes. Now, coming back into the 21st century, I'm sure a lot of you may recognize these. These are actually 5 gigahertz sector antennas. Now, we're not getting into cellular phone work here. These are actually used with ubiquity wireless access point routers that has had their firmware updated to now allow us to use them for ARRL, or amateur radio digital, or amateur radio emergency digital network. And these are set for 5 gigahertz. These antennas with their routers in the back, and kind of swap around here. If you can see that, the router's kind of in this box here. These are going to be mounted on our 120-foot tower as part of an experiment. We're going to be coupling up with the radio station, the amateur radio station, W1TMS, located at the Talcott Mountain Science Center, as well as a few other points for ARRL experimentation. In addition to the 5 gigahertz, we also have, and hopefully you can get an eye on this, 2 900 megahertz systems for ARRL, for the Amateur Emergency Digital Network, Data Network, and of course you might be able to make out one of the wireless access points there, the ubiquities. They're just standard units you can buy off of Amazon or directly from Ubiquiti, used for home WAP access, and all we're doing is just modifying the firmware. So we're going to bring it back over into here. Now, I briefly mentioned the towers. Again, we have 3 60-foot towers and 1 120-foot tower. They're self-supporting, although there are fences all around them. I do have a contractor that comes down twice a year. We are required to have inspections twice a year, and as staff, we cannot do that. The inspections have to be done by qualified, licensed, and insured tower climbers, because in the world of insurance, we are considered a radio station. They understand we're ham radio, but we're a radio station, therefore we have to have this done legally and properly. So my antenna work is done by a qualified, licensed antenna climber. If I have to have repairs done or installations done, it is normally done during these 2 inspection times. If I have damage or something needs to be repaired and it's critical, then that is done off schedule. But again, all done by our contractors. So that's pretty much it. That's W1AW in a nutshell. We're open Monday through Friday, normally open Monday through Friday, from 10 to 12 and then 1 to 3:45 for visitor operations. And we hope if you ever have an opportunity, when things calm down and we're able to get visitors back here again, that you can come to the station, get on the air, and have some fun. I'll see what I can do about helping with the sunspots to improve on band conditions.
All right, Joe, thank you very much for that tour. Let's bring Joe back on the screen. There he is. All right. Thanks, Joe. So we'll get to some questions and then we'll have you show us what's going on live behind you.
Okay, awesome.
The first question is, I was there over 30 years ago and signed a visitor log. Do the visitor logs get saved?
Actually, they do, yes. We still have all the visitor logs, pretty much going back to when we started with visitor logs decades ago. But from even 30 years ago, I do have those logs. Most of them are kept in our archives in the main building, although I have some of the new ones from the past 5 or 6 years. They're located upstairs in the attic area, W1AW in storage.
Great. Next, what frequency do you broadcast on at 2 meters?
147.555 megahertz FM. All FM, all the time.
Is there any block diagram of the station equipment?
Not really. And the reason for that is it kind of changes over time. It's never a static setup, whether it be for the operating positions or even for the equipment here. Now, if someone wanted a diagram, I can easily supply them with one, but I normally don't keep it only because I would, in some respects, constantly be changing this thing. And
once HQ is open normally, Do people need to schedule a visit to W1AW, or can you just drop in during those open hours?
Pretty much it's first come, first serve. And that's normally how we normally did things. If people would show up at the door, they would come right in. Now, I do have some hams that will call up to say, hey, I'm going to be in the area. Can I come by? What would be the times I can operate? That works. If they're in for a tour, they take the tour first, and the tour always, tour of ARRL headquarters, the tour always ends here, and then I can get them on the air. The only time I ask if people would call ahead would be for large groups. So if, say, you and a bunch of your friends are going to be coming up and you want to operate the station, I just ask for like a day's heads up. This way, if something is going on, if one of the studios happens to be in a mess because I'm pulling everything out and putting it back in, I can get everything coordinated for you. But it's pretty much just come to the door.
Great. Can you comment on the lightning protection schemes, and do you disconnect antennas during lightning storms? How does that work?
Well, as you saw in the video, generally all the antenna connections for all of the visitor operating equipment is normally left disconnected. The only equipment that is normally left connected is the actual transmit equipment. That's the stuff behind me. For lightning protection, each tower leg is grounded to its own individual ground rod, an actual 8-foot ground rod, using the shortest amount of wire that I can get away with. I mean, obviously I have to deal with a concrete base, so there might be a couple of feet, but each leg is grounded individually. In each tower box, that's the transition from the cables coming down from the tower to the cables going underneath into the building, I have polyphasers mounted on large ground planes within the box. Now, though that polyphaser ground plane is also attached to one of the ground rods, I try to bleed off as much energy as I could there. Now, where the connections come in, the hard line comes in from outside. Those connections go to a very large ground plane, kind of like the one I mentioned in the video. Now, that large ground plane that has bulk head connectors through it, you know, like PL258s almost, that panel is connected to our electrical ground, the water ground. I would say telephone, we no longer have a wired telephone system anymore here, so that's disconnected. But the electrical, the water, and actually to the grounding system here at the station. On either side of the station, I have 8-foot ground rods driven into the ground. They're connected with a single run of 2-inch copper strap. So all that is connected to the station ground as well. From that station ground, I have connections coming up to each one of the studios, and there's a bus bar in the back of each desk. And if I can get a ground wire on a piece of equipment, radio, computer, whatever, it goes to that ground rod. So is it perfect? Well, it's kind of close. Have we taken lightning hits? Of course we have. In fact, there is one that I know of specifically that occurred in June of 2006. And you're probably wondering, well, how do you know that? And I said, well, that actually occurred just after 4 o'clock on a weekday. It was one of those, you know, late spring thunderstorms that normally crop up here in New England. It was raining like mad. Staff were waiting underneath the main foyer there, the overhang there at ARRL headquarters, and they actually saw my 120-foot tower get hit by lightning. Now, that was after 4 o'clock, so we were transmitting, but we didn't know that we took a lightning hit. My operator did not notice any change in the equipment. There was no highest ISR readings or anything like that. What was interesting is that the only damage, electrical damage that I can see, was a capacitor had gotten blown out in one of the rotators. We use R2800 Orions up there. In addition, the concrete from one of the posts that supports the fence around the tower, that one, the concrete was actually blown off, like somebody was chipping at it. And the moss that had normally grows around those either sides actually looked like somebody was scraping it up. So we're surmising that the lightning, it was a weak strike, clearly, probably traveled on the outside of the tower, hit that one fence post, and then dissipated into the ground. It heated the water, it instantly vaporized and expanded, it took out the concrete a little bit, and as well as the moss. But other than that, I think we're fairly lucky overall in terms of taking lightning hits. 2 trees that we have on either side of the back of the station here, they've been taken out by lightning, but knock on wood, I think we're fairly safe. But that's pretty much what we do for all lightning protection.
All right, thanks, Joe. And what distances are you looking to make for the 5 gigahertz Arden connections?
Those are very close. I had mentioned in the video that we're going to be working with the Talcott Mountain Science Center. They're located in Avon, Connecticut. They're to the northwest of us at about, I think 10 miles as the crow flies. And that is an experiment at 5 gigahertz. Now, the interesting thing about that is where they're located, they're rather high up. So they actually have a line of sight from their location in Avon to us here in Newington, because we're actually kind of in the valley here, the Connecticut River Valley. So if we can get through that distance, that's fine, because that is all part of the experiment. Otherwise, the system around here would only be for local coverage. We're so much in the valley here. There's so much stuff around us. We have a very high ridge to the east of us. Actually, it actually overlooks the towers here. That any amount of distance at all we can get on the 5 gigahertz would be great. But again, with that experiment with Talcott Mountain, that will be a line of sight. And since it's 5 gigahertz, we don't expect to get miles and miles of distances out of it.
Next, can you tell us again why the call sign is W1AW?
That was Hiram's call. When he was standing in line like everybody else, he was initially issued 1AW. And when the FCC at the time, the communications at the time, had to put letters in front of those numbers, he just happened to get W. So that is really the only reason. Rumor has it that he wanted to be 1AA. And rumor has it that the only reason he missed out was because he didn't get in line. So, but that's the only reason why his call was W1AW.
Great. We're running low on time. So, Joe, what's going on behind you on the screen there?
Well, I'm going to move my head out of the shot. Right now, it doesn't look it because it's slow. These transmitters are actually transmitting the 4 p.m. Eastern Time slow code practice. And you might just be able to make out the displays on the radios or the amplifiers showing the power out. As part of the demonstration, part of this webinar, I actually have our spectrum analyzer attached, and it's looking at our 40 meter frequency of 7047.5 kilohertz. So if the lighting's good and you can see it, you can actually see the peaks when it's picking up the RF. I'm just sampling off there. I'm not injecting a signal into this thing, otherwise I let the smoke out of it. But that's what we're transmitting right now, and we're on 160 through 10, including 6 and 2 meters.
All right, time for 1 or 2 more questions here. Few people have asked, what about the equipment that Joe Walsh donated a while back?
We received donations from Joe Walsh and Bob Heil of Heil Sound back in 2004. That consisted of an NC303 and the Johnson Viking. That equipment lived here for a little while. Unfortunately, or fortunately, depending on your point of view, it saw no use. The fact that the Viking is an extremely finicky transmitter, I was always hesitant to let someone use it if they didn't know what they're doing. If you came from the time of having to dip files and so on, and you were familiar with how the Johnson worked, that was one thing, the Valiant. But in this case, it didn't see a lot of use. So that equipment was actually moved back into our ARRL laboratory, into their museum section. So when we do open up for tours again, hopefully, and you take a tour of the organization, you go into the laboratory, they will take you through the museum. Those 2 pieces of equipment are on display inside the museum area.
Great, we have time for one more question here. Curious about the patch panel and why the round circles with no paint around each connector.
I'm not exactly sure what you mean. On the patch panel?
Yeah, that's what the question is. Hard to get more details here.
Well, it actually depends upon what that particular connection is, because I have a number of them. All these connections go to either the antennas on all the towers or to radios in each one of the studios. I have a connection that actually goes over to the ARRL laboratory. We ran some LMR 400 last year, so the lab can make use of my antennas here. So it really depends. Some of them are marked what they are specifically. Others are blank because they're just spares. I always make sure that I have a few extra spare connections just in case. And that's what you may be seeing. It's just that happens to be just a blank connector that's there in the event I need it for any other connections. Does that answer the question?
I believe so. So thank you very much. And thank you for your time today, Joe. We know that not all of our members and not all amateur radio operators can get out to Newington, Connecticut to see W1AW. So it's great that you've taken some time to show everybody around the station.
Oh, and thank you very much. Thank everyone for attending. And if I may, a shameless plug, one of the things that we do here at W1AW is we will provide Zoom presentations to clubs. So if your club would ever like to see the station via a Zoom presentation, just email us here or call us here and we can schedule a time. Normally, we will hold the presentations during a club meeting or usually at the start of a club meeting. And it doesn't matter whether the club meeting starts at 7:30 p.m. Eastern time or 7:30 p.m. Pacific time. If you have a club meeting and you'd like to have a presentation of W1AW, just let us know and we'd be more than happy to oblige.
All right, thanks again, Joe. Now it's time for us to wrap up. So a reminder to visit our Learning Network webpage for a schedule of upcoming webinars and recordings of this and our other presentations. Go to ARRL.org, click on the webinar link under the slider or do a search for the Learning Network. Our next session is Talking to Astronauts in Elementary School's Exciting ARRIS Contact, and is being presented by Diane Warner, KEAHLD, and that's on Tuesday, March 2nd at 1 p.m. You can find information for that on our webpage. And we're also always looking for presenters, so if you have a topic that you'd like to present, we'd love to hear from you. There's a call for presenters form on our webpage. So thanks again to Joe for his time showing us around the station, and thanks to all of you for attending today, and have a great day.